Hello, hello. Something's just gone off. And it's back on. Yeah, so I originally proposed the talk as a deep dive, but I've got 25 minutes, so it's a surface dive into the pricing. So yeah, jump right in. So as Lorena said, I'm Donal Murray. I work in the system parachains team at Parity, and I'm also on the Polkadot Fellowship. So yeah, we'll jump in. So just as an overview of the talk, we've had a few really good talks about core time so far at Decoded, and there were a few earlier in the year at Sub-Zero and Polkadot Summit. So I don't want to hang around too much on introductory material. It's going to be very much more about, like we're in the tech stage, so it'll be a bit more technical. Hopefully we'll be going into detail that's relevant for builders and parachain teams who have got open questions. We'll hopefully have some time at the end for discussion, because I know there are still a lot of open questions and things that are unclear. But I hope to clear some of those things up in this talk. So I'm going to have a brief, I've called it a reminder of the Agile core time aims. So just going to skim through those and then go for the SEAL architecture, then the pricing models and considerations for when we're making these models. And then just briefly at the end, upcoming developments, just because it's a good platform to talk about that. So the reminder, Agile core time, we have these three first aims. So we want more flexible core time procurement, lowering the barrier to entry, and encouraging maximal block space utilization. So these are all a kind of an improvement over the previous, over some of the drawbacks of the previous paradigm. And then we have these secondary aims of keeping some price predictability and even arguably improving that. Previously, you would have 2 years, and then you have no idea whether you're going to be able to get a slot or whether things are going to go your way, how much it's going to need to cost. So price predictability, and then also this market-driven price discovery to land on a fair price. And like, since we're burning the revenue, it's not that we're trying to maximize the gains for some group of people. We are trying to make Polkadot as accessible to build on and as kind of like a good platform to build on for the long term as well. So these two last ones are kind of those two aims that make things a little bit more difficult. We'll get into that later. So the division of work, this kind of getting a little bit into the architecture. We have the core time chain, which is a system parachain. So we're taking the marketplace and allocation. So the kind of the driver of core time allocation is the core time chain. And then we also have the adding regions to the on-demand pools and then claiming the revenue from your contributions. That's all done on the core time chain. What the relay chain does is obviously the fulfillment of the bulk scheduling, and that's definitely not an only. That's a huge amount of heavy lifting. But since we're talking about pricing and economics today, we're going to focus on the core time chain and talk a little bit about on-demand. But the economics of on-demand are like a little bit derivative of the bulk core time pricing and economics. And yeah, so also in the relay chain, the on-demand procurement and scheduling happens directly there for low latency. So going into the actual core time chain, we do this through a periodic Dutch auction. I'm not going to go into too much to the Dutch auction, but anybody who's heard me talk about before knows I talk a lot about fish. Selling fish is a good analogy for it. But so Dutch auction, the long and short of it is the price starts high, drops over time with some defined curve, and ends up with a fixed price at the end. We have baked-in renewals, so that renewals are kind of something that's supported at the native level, and that's to go towards that stability. We aim to have this price-finding mechanism where, based on performance of prior sales or performance within the sale, we can work out what the renewal price and the price for new core time will be. And then we have these operations, which I see as like I mean, you can use them as they are, but it's kind of like a layer for secondary markets to tap into and for them to integrate with. So being able to partition, interlace, these are different kind of manipulations of the core time regions, or to transfer and assign. So We'll kind of talk about that a bit more later, but I'm going to kind of ignore the ins and outs of partitioning and interlacing, just because focusing on pricing. And the last bit is about the pooling and contributions. So one of the things that you can do with your region of core time after you've bought it is that you can say, I don't want this core time to allocate a parachain to. I want to actually try to earn money on this through pooling the region and getting a cut of the kind of revenue from on demand for that period that I've pooled the core. So to achieve this, obviously, I've said about something that falls over time and something that happens in stages. And so a really key part of the broker palette architecture is the tick mechanism. So we have this, every block we have stuff happening. So every block we're processing the updates from the relay. Every block the price changes in general, depending on what part of the sale you're in. And then these things, these time slices, which are a group of blocks, 80 blocks long, which are, you can kind of think of them as being the amount that is allocated in each. It's like the fundamental amount that can be allocated in a work plan entry. So the flow is for the tick to just process the on-demand pool input and output. So if somebody pulls a core, or if somebody removes a core from the pool, we need to update the availability and let the relay chain know, like, OK, somebody's just withdrawn a core, withdrawn a region from the on-demand pool. So there is X fewer blocks available to be bought. After that, it processes the work plan. The work plan is the entries of every upcoming allocation that has been assigned on the core time chain. Then we go on to requesting the on-demand revenue. So that's just message passing, kind of, we request that from the relay, and then the relay will send that back, and we'll catch that in the every block part. And with that, there are two parts of on-demand revenue. There's the ones that come from the system cores, because the system can reserve a number of cores purely for on-demand availability, and then the ones that can be contributed by people in the ecosystem, so that they buy a region and they put it into the pool. So these are the two, I've called them private and the rest. So it's private and system. Oh my God. That's not good. Try to work with it. That means I've been talking for too long on the tick. But so, yeah, the private contributions will be distributed to those who contributed cores in the ratio of the amounts that they contributed. And the rest, so the system part of it, is burnt. And that is burnt along with all of the bulk revenue that comes in. So the periodicity, this is like a kind of a classic gotcha, a big gotcha. Can we, yeah? So the question is about what is the block latency, just for the recording. Yeah, so the intention is for 6 to 12 seconds, I think, to have that as the latency. But I think that depends on the demand. Yeah, probably not the best person to ask about the on-demand part of the implementation. But we can have a longer discussion at the end. I'll just try to whip through these, and we can talk about the ins and outs. So yeah, the periodicity. When we're bootstrapping our way in, we have this part that we call start sales. So then we have period 0, period 1, period 2. And in these periods, you have the sale itself. I don't know if I can point. Can I point? OK, I can point, but you can't see. So I can actually point. Inside this, we've got a sale which lasts for the length of the period. But the periods also represent the length of a region that is sold in the prior sale. So the sale periods are 28 days long on Polkadot and Kusama. And that's the same as the length of bulk regions. So when we migrate from the slot auction model, or the leases and slots model, we populate the legacy leases on the core time chain, and we keep those on a core. And until this point, at the first rotation of sale, the core time chain isn't controlling what is running on the relay chain, that's still being controlled by what the state was at the migration. So at the point that we start the sales, this is where we account for the reservations and leases, where we're basically saying the total number of cores, take away the reservations, which is the system cores and the cores that are set aside for on-demand. Then we say, right, now we have this number of leases, which are the leases that are migrated from the old slot leases. And they will have their end point at some future point in time. So they're accounted for in the migration. Then after that, we configure the pallet. And then we call start sales. And so when I say there that the reservations and leases are accounted for, they're actually then scheduled to happen here at the first period. And so in this period 0, this is like a bootstrapping phase where we obviously don't have a prior sale. So we don't have any regions that have been sold that people have been allocating. So at this point here, we don't have anything running from the open market, just the leases and reservations that exist. So in the lead-in period, we'll see what that actually means in a second, but essentially from the lead-in through the fixed, you can buy cores in period 0, which you can then assign to your parachain for period 1. And at the end of period 0 then, we have this first rotate sale, which we'll talk about in a second. So sorry about this. I should have increased that timeout. So yeah, after that, I've said that like the bootstrapping phase is kind of atypical, but after this, we've got the interlude, then the lead-in, then the fixed period. So the renewals happen inside the interlude, where you have, if you already have a core, you have priority about renewing that. So you can kind of snatch a core before anybody in the open market has a chance. And then you can also wait. You can wait for the middle of the sale or wait till later. But the risk is then that the cores will sell out and you won't be able to get your core again. So yeah, the open market part then happens after the interlude, where you have the start of the pricing adaptation. So the lead-in period and the fixed period are just changes in price, but it's the same mechanism where anybody can trustlessly purchase a core and assign it for the next period. And then we rotate the sale. So rotating the sale is just kind of cleaning up what happened and doing that same thing of one sale in advance, allocating the reservations and the leases, and then saying, right, now we have this number of cores left to sell for the next period. So like I said, the rotate sale additionally processes the revenue for the sale that has just happened, so sale N. We allocate for sale, or for period N plus 2, and then we also work out which cores or which parachains can renew in the next period. So the renewals, excuse me. So if you stick by the rules and you assign your core in a way that you haven't split it, transferred it, no reselling or changing the bulk region in any way, you can have a potential renewal. So I'm just going to drink some water. Your potential renewal just is put in the period before you can renew. And so when start sales runs here, it's saying whose lease or whose block, region is ending within this period. And it says if you're ending within this period, then your lease disappears from state, but you're allowed to renew. And the time that you're allowed to renew will be inside this interlude. Sorry, so that's one sale in advance. Dry throat. So the last thing that's done then is for the prices to be adapted from sale 1 to sale 2, or sale N to sale N plus 1. So I've mentioned about renewals, about how they're kind of like a native part of the system. The thing that has changed with the new pricing model is that you pay a slight premium unless the prices go like really far down. So previously it was that you had preferential rates, and you might pay more, but it's capped, but you might also pay the market rate, whereas now we have it changed where it's definitely going to be increasing unless you get like a 10 times lower target price. And with this, you're sacrificing the flexibility of being able to partition or interlace your cores, your regions, for this stability and the price predictability. So you're kind of trading off a low price for one that you can tell is going to be the same or some progression of that long into the distance. I've heard a lot of misconceptions about renewals, and I had this slide, and when I was sitting in Mathieu's talk, I heard a few more of them coming up again. And so I just wanted to clarify a few of them, that, yeah, so you renew in the sale before the lease runs out. You might have a potential renewal before that, but the potential renewal is, the timestamp on that is the end, like, so when it's the it's hard to talk about. It's the block that you can, that your renewal will start, but you have to actually renew that at the start of that period in the interlude. So you're kind of like calling renew so that your renewal can happen at the time that your core runs out. So that's like a sort of a time stamping issue where some people interpret that as I need to renew after this point, or I need to renew whatever, some other interpretations. So you need to renew it in the sale before the lease runs out, preferably in the interlude, so you've got that reserved core. Your lease renews at the target price, which you'll see in a second. The cores you've paid for, so that's like not leases. So if you buy a core on the open market, or if you've already renewed in the past, the sale before, whatever price you've paid there, you'll renew at that price plus the fixed increase. And yeah, this one here about renewals counting as cores sold. I see it in a few UIs that it looks like, or maybe this is the older versions, but it looked a bit like things were being sold. People were buying cores before the buying period actually started, but these are just renewals happening. And yes, auto renewals are coming. That's one that I added in just after Mathieu's talk, that we have this PR that's pretty mature. It's in the final stages of review. And yeah, thanks to Sergey for that. So, pricing. We have this new model where we have a kind of, you can't really tell here because previously it was just basically the same thing. If you hide the amounts here, it would look like the same kind of graph. But the progression between sales previously had to do a lot of lifting, which meant that there wasn't enough kind of scope for the price to change within a sale. So this is like, as you can see, a sort of a bounded approximation to an exponential decay. Bounded in that we're specifying, if you see an exponential decay, depending on the parameters, it can be really steep and then very shallow and sort of a tight corner. But we want to kind of get away from that so that the corner's less tight and we have more of a spread of prices where we have a window, no matter whether the supply dips for some reason. Lots of people renew, not many cores are in the open market. We want to have it where we can handle that increase in demand or decrease in supply without having to wait for a full month for the adapter to change it. So it means that we can then make that inter-sale progression less aggressive. So you can imagine this decrease in price is what I've called the intra-sale, so within the same sale. Whereas what happens at the end of this time, so this is 28 days. After this 28 days, you go from one sale, the sale is rotated, parameters change for the next sale. That doesn't need to be as powerful or like be given as much control when you have such price finding power within the same sale, because we've got a 10x. So the target price is in this little corner here within the lead-in period. So we have like the target price as, like I've called this 1x and 10x. The implementation is slightly different, but this is a kind of a better way to conceptualize it, in my opinion, to have this target price, which is where you get the lease renewal price, and this should kind of be the expected market price, or what you think that is, your best attempt at guessing the market price. So it starts off at 10x. That's the lead-in factor being 10 times that. So say if you start off at 10 dot and increase it to, it starts off at 100 dot, decreases linearly to 10, and then we actually go even below that, so that if the price is too high in a sale, we don't just not sell any cores or we don't have these kind of dead sales and then live sales where you have these huge fluctuations in price between sales. So yeah, I've actually already covered that. So I'll keep going on. So as I said, like this change in the pricing model was based on some Kusama data, where we had this like low stats environment that we had seen before, we knew before, where we only had 3 cores in the open market because we had so many teams on a lease. We have a fixed number of cores in the system, so you don't have many that are available for the open market each sale. So at the start of the Kusama sales, we were like, right, we want to have cheap prices. We only have 3 cores. Let's put it at 5 KSM and see what happens. And what happened was people bought them and didn't do anything with them. So you can see that as like a failure in the system in one of the, I'll not flick back, but one of the main things is to maximize the usage of the block space. And so if you have a situation where the system isn't doing work, somebody's able to buy stuff and not do work, and like not really be penalized that much apart from that the price that they paid. But then what they are doing is they're then penalizing the people in the next sale, where just because those 3 people, or maybe just one person, I don't know who bought them, just because they think it's worth 23 KSM doesn't mean everybody in the next sale thinks that that's the base price. People might think it's actually worth a little bit less than that, but we didn't have the ability within a sale to drop down below 23 KSM. It went from 5 times that to that. And so we had a bit of a 3 cores sold right at the start of the lead-in period, and then no cores sold, or maybe 1 right at the very end. I can't remember exactly. So yeah, that's what the new model, the kind of motivation for the new model. The additional thing is that we have more cores in the system. I don't know if everybody has tuned into this, but there was a referendum that was executed there which has upped the number of cores in Kusama to 100. And so the system already has 100 cores. The core time chain just isn't taking that into consideration yet until the next sale is rotated. So I think that'll be really interesting when we have those additional 50-ish cores, or 40-ish cores. I've already talked through this. I should have flicked the slide over. And yeah, one of the most important parts that happened with this change was that the actual way the palette worked was changed. So fewer things were hard-coded within the palette and were left to an implementation in the runtime. So it's much better for being able to change things on the fly or experiment a little bit in test nets, is to take it out of the palette and into configuration. So yeah, I just talked through about 5 slides without changing the slide. So yeah, that's an extra slide. It's not meant to go down to that. So yeah, with the increase in core count, I think that the next few sales will be very interesting on Kusama, because now we have this pricing model where you can get access to these lower prices, and we also have these additional cores. I think we're going to see a lot more of a scenario that will be similar to the kind of end game of core time, where all of the main parachain projects are off their lease and into the open market. Either they might be renewing, but they're definitely active at buying, splitting, interlacing. I think this is all more likely when we have more cores. This will be proposed on Polkadot soon. Trademark. I can't give any. I don't really know when that'll be, but at some point in the near future, depending on how it goes in Kusama, that'll happen, and we'll probably have to have some change, sort of like take these implications into consideration and make some edits to the pricing models. There are just a few kind of speculations here with question marks. Like, yeah, we'll talk about that if anybody asks any questions about it. So just a brief rundown of what's coming up. We have the Polkadot launch in August. It's likely to be a similar pricing model, maybe with a few tweaks. There's an auto-renew palette in the works, and we're probably going to change it in the future. So, got any questions and some references here.
So my question is basically around, I feel like there are some assumptions that number of cores always increase, because what happens if number of cores decrease? I imagine the situation where there are, I don't know, 10 cores being assigned, 10 cores that want to renew in the interlude, and in the next sale there are only 8 cores available. What happened? First come, first serve? How are you thinking that?
So that's in the case that the system reduces its total number of cores. I guess that in that case, we would know about it in advance, because as the number of validators decreases, that'll put pressure on us to decrease the number of cores that are available. That'll be something that will be done through governance, and people can then make the decision of whether they want to use these functionalities, like manipulating regions, to say, right, I know that I want to get a core, but I could sacrifice 6-second block times and get 12-second block times. Does anybody else want to do that? And then you could make things in a smart contract or use a secondary market to enable you to do that, where you can buy regions, split them between 2 teams or 3 teams, and that's a pressure that wouldn't only happen if we reduced the cores, but when we get to the point where all the cores are fully utilized, then we'll have the same pressure, where teams will be hopefully financially encouraged into sharing cores and splitting the regions in those ways.
Yeah, adding to this, first of all, I hope we don't reduce the number of cores. But if we do, ideally, we have time to do it. And then we also have, first of all, renewals are preferred, right? Renewals are happening before anything else. That means if you're not reducing the cores too much, at least renewals are still guaranteed. Oh, between the renewals, I guess it's first come, first serve in this case. But this is an edge case we should really avoid.
And I think that in reality in the system, because it's you can trustlessly buy core time, I don't think that we're going to end up where we have 100% renewals. You know, if we go to a small core future, which I hope we never get to, then maybe you could see a kind of an attack vector to buy that up, but it would become prohibitively expensive due to the market-driven pricing. And there's like an escape hatch where if things become really bad for some unforeseen reason in the future, you can still, through governance, assign these things. You can say, I think these 5 projects should share this core, and we can reserve that as a governance call, and then that means that they have preference over all else, even over leases.
So yeah, and one thing, we are going to 100 cores on Kusama, and the goal is Polkadot should always have less cores, right? So Kusama is the canary. So if there are any issues, it should happen in Kusama first, and we should never have to do this like in an emergency on Polkadot. And if there's no emergency, like for some reason we have, I don't know, some protocol change and we want to reduce the number of cores, whatever, we can actually have a parameter, desired cores for sale, which is not a hard cap, but just reduces how the price goes lower. So we can, yes, yeah.
Yeah.